Okay, good morning. So, yeah, let us see how it goes. This is the most important part of this lesson of absolute values. We are supposed to learn how to solve equations and inequalities containing the absolute value sign. So this is a little bit technical. It's not hard, but you need to follow some steps to be able to guarantee that you can solve all of them always. Okay, so the book has started with actually a very harder example in the beginning, but let me try to motivate you what we can do. So let me write as an example. So example, I want you to understand this one as well. But the method that the book describes, I will also discuss about that. That is the most general strategy to solve these kinds of problems. But sometimes there are shortcuts. You don't need to go through those long processes. Okay, so for example, I ask you solve the following equations. Okay, so number one, for example, let me write this. Absolute value of 2x plus 1 is equal to 5. I want to solve this equation. It means that I want to find all possible values for x so that when I substitute those values for x in the left hand side and calculate, it becomes 5. So that is the meaning of solving an equation, yes? I need to find all possible values for x. We can solve this in a general way that I will describe later. But even if you know the general method, it is easier to do this shortcut here by understanding it from geometrical points of view. So you are asked to solve this. You don't know this package. This is not known to you. The reason is that you don't know x, so you don't know the whole package. But you know that when I take absolute value of this package, the answer becomes 5. Okay? So what does it mean? What are the only possible values for 2x plus 1 so that absolute value of that becomes 5?
2 and negative 2?
No, I'm just talking about the whole package. 5 is one option, because if that is, and minus 5. So these are the only ones. So you really don't need, if I give you this, if you want to solve this, you would say absolute value of 2x plus 1 equals to 5 implies that, or you can write it in a vertical manner. If you want to go horizontally, you need to put these arrows, but if you want to go vertically, you can just write 2x plus 1 is equal to 5, or 2x plus 1 is equal to minus 5. Okay? And then what you need to do, you need to solve each one of them. So I move this one to the right, it becomes 5 minus 1, 2x becomes 4, and x becomes 2. That's one answer. So one of them was actually 2. And the other one, I will start solving. I move I move 1 to the right, it becomes negative 5, negative 1. So 2x becomes negative 6, and I divide by 2, it becomes minus 3. So the answers are two numbers, 2 and minus 3, nothing else. And of course, if you want to check, you can check it. Put 2 here, 2 times 2 is 4, plus 1 is 5, absolute value of 5 is 5. You put minus 3 here, 2 times minus 3 is minus 6 plus 1 is minus 5, but again, absolute value of minus 5 is 5, and there are no other numbers with that property. So that is the solution to this problem. Yes? So you really don't need to solve it harder than that. So, but let me write another example here for you. For example, let me write absolute value of another absolute value inside, x minus 1 minus 3. And then let me write absolute value closed is equal to 7, for example. Okay, again, you need to interpret it in this way. You don't know x, so you don't know this expression, and then automatically you don't know this. Yes, we don't know this part, but we know something about this missing part. We know its absolute value is 7. Yes? So what can I conclude about this box, this black box? I don't know anything inside that, but I know that this absolute value is 7. So what can I conclude? I can conclude that x minus 1 minus 3 is either 7 or absolute, yes, x minus 1 minus 3 is negative 7. This is for sure, otherwise this will not work. Yes? Is this a step understandable for everyone? Yeah? Okay, but then I want focus on one of them at a time. So here I want to find this package, but I don't know this, but I know something. This is a number, so that minus 3 that number minus 3 becomes 7. So what is the meaning? This number is known to you now. X minus 1 is equal to what? I move 3 to the right, it becomes 10. And again, this is our old lesson here. Absolute value of a number which is not known to me yet is equal to 10. So there are only two options available for x minus 1. So then this means that x minus 1 is equal to 10, or x minus 1 is equal to minus 10. Yes? And then if I want to find x, this is very simple. I move 1 to the right, x becomes 11. This is one of those answers that I was looking for. Or I move minus 1 to the right, it becomes positive 1, negative 10, negative 9. Yes? But this is this part of the story. I need now to go back to this part, but this is simple. I move minus 3 to the right. What is the answer? I move minus 3 to the right, it becomes positive 3, and I have a negative 7, it becomes negative 4. And then how should I continue this now? Yes?
You then have the absolute value of x minus 1. You know that it's either minus 4 or plus 4.
No. You shouldn't just start doing something blindly. This is not possible, yes? Because I told you, do you remember last time, I told you the output of an absolute value cannot be negative. So it doesn't matter how hard I try, it doesn't matter what I find for x, absolute value of a number is not possible to be negative. So you say that no solutions. Yes? So the only solutions for this equation are 11 and minus 9 from this part. From that part, I will not be able to get any solutions. Yes?
Are there no solution at all, or are there only no real solution?
No, this is not at all. No, not at all is not a good word, yes. Yes, it is not at all. Because even if you go to complex numbers, this means distance. And distance cannot be negative. So it doesn't matter. Yes. Even if you go to complex numbers, there is no solution. Yes?
Does it have any meaning to put a negative sign before a
Yes.
value?
Yes. So this, for example, if I ask you to calculate minus absolute value of 5, then you would say that the absolute value of 5 is 5, but I have a negative sign, it becomes negative.
So couldn't you multiply both sides by a negative
Yes,
sign?
you can, but then the problem is that this becomes negative, this becomes positive. Then
And wouldn't that work?
no, that's not. Yes? Okay, so number 3, let me add one more here. So let me write something for you, okay? This might be a little bit more tricky, but I think you can solve it. So 5 minus 2 absolute value of 3x minus 1 is equal to 6. Yeah, let me make it, yeah, 6 is good. So I will pause recording for a moment so that you can think about this problem. Okay, did you get the answer?
Not yet.
Yes, what's the answer?
There are two answers. One of them is x is equal 13 divided by 6, and the other one is x is equal negative 3 divided by 2.
13 over 6?
Yes.
And the other one?
Negative 3
over 2. Okay, so let us test this. I want to know if GeoGebra is capable of solving absolute value equations as well. So here, if I want to solve this using GeoGebra, so you open GeoGebra, but I think we have to switch the view. So we go to the, let us go to CAS view. And we don't need algebra view, we don't need graphics view, so let us get rid of them. So again, you go here and start typing your equation, probably. So let me see if I can manage everything. So you just press solve. So then you will get a lot of options here. But solve equation in X is probably what we want to do. So we go here and click here and then start typing our equation. But our equation is absolute value. So if I remember correctly, it should be ABS. So you see ABS means absolute value. I don't know why it didn't work. Okay, I didn't choose. Okay, it worked. It worked. And then you put 5 minus 2 and then again absolute value. Yes?
You wrote plus.
Oh, minus, yes. Minus.
No.
And then...
That's plus. No. Plus.
So what? It's a Swedish keyboard. So I have to change the Swedish keyboard to US keyboard and then that's better. So 5 minus 2 absolute value of what? Of 3x minus 1. Am I right? And then outside the bigger one, I should put 6.
Yes.
Yes, hopefully this is the way that, so we, in principle, it accepted that. So your answers are correct, yes. So minus 3 over 2 and 6 over 13 over 6 are actually the correct answers. Let us keep GeoGebra here and then try to solve the problem here. So why those answers are correct, so we can go up to here. Good. So I see, I will consider this a package or a black box. I don't know what is inside that package, but I know that absolute value of that package is supposed to be 6. So what are the possibilities? There are only 2 possibilities. Either this package is equal to 6 itself, or 5 minus 2 absolute value of 3x minus 1 is equal to minus 6. Agree? So these are the only possibilities. But then it is not hard. I move 5 to the right, so I keep minus 2 absolute value of 3x minus 1. I move 5. Let us do this in our head. Yes, 6, 5 goes there. It becomes minus 5, 6. It becomes how much? It becomes 1. Yes? And then I want to find this package. I divide everything by minus 2. So absolute value of 3x minus 1 becomes minus 2. Okay, what should I continue or not here?
No.
Everyone, yes. We shouldn't continue because absolute value cannot be a negative. So no solutions here. So no solutions here. But then here, if I continue, I move 5 to the other side. It becomes minus 2 absolute value of 3x minus 1 absolute closed. And then I move 5 to the other side, minus 6 minus 5. It can be done in our head. It is how much? Minus 11. And then I divide everything by minus 2 to make this absolute value alone. Minus 11 divided by minus 2 is positive 11 over 2, and I prefer to work with fractions. Of course, here, this is exact value. If you want, you can keep it exact. But when I see the answer, one of the answers is not, if I want to write it in decimal forms, it is not exact. So let us work with fractions. Now, from now on, everything should be clear for you. Then I have two options available. So 3x minus 1 is 11 over 2, or 3x minus 1 is negative 11 over 2. Yes? Then I will solve the first one here. So 3x minus 1 is equal to 11 over 2. You move it to the other side, so it becomes 3x is equal to 1 plus 11 over 2. So 3x is 13 over 2. And then you divide everything, because your goal is to make x alone, by 3, and then x becomes this number. When you divide it by 3, it becomes 13 over 6. And that's the number here. And then, of course, I have another solution, another equation to take care of. So I write 3x. I move minus 1 to the other side. It becomes minus 11 over 2 plus 1. But then it becomes 3x. If I simplify that, instead of 1, I can write 2 over 2. So it becomes minus 9 over 2. And then if I divide everything by 3, it becomes negative 3 over 2. I hope that you don't have problems with working with these fractions, yes? For example, here I divided 3 over 2, I divided it by 3, but you know the division rule is to write this multiplication and write the reciprocal here, which is 1 over 3. So this is why the answer becomes this, and the same story here. So these are the answers that we get, yes?
So didn't we say that the absolute value could be like something like in parentheses as well?
Yes.
Somehow. So what would happen if we just multiply the negative 2 inside the...
No, I didn't say it is like a brackets. If that's like a brackets, why we bother to study absolute values? We study brackets.
So
But I told you...
No.
No, do not invent rules, yes? Of course, here in this case it is possible, but you are allowed only to multiply 2, not minus 2. Okay? So if you multiply minus 2, it will not work. Be careful about that. Might be that was a misunderstanding from my, or I don't know, bad explanation. But I told you that when you have 2, absolute value of x minus 3, okay, if you want to remove this, you shouldn't write it like this. Whenever you are sure that this is positive, of course you can eliminate that. But if you eliminate the absolute value sign and write it like that, that is wrong. In that case, you have to put a pair of brackets. This doesn't mean that when I see this, I can multiply 2 inside.
So it wouldn't, if you say 2x, absolute value of 2x minus 6, that wouldn't be right.
Yeah, that is right.
That is right.
But, that is right, but because you don't know the rules, that would be a coincidence. Because when you multiply the negative sign in, it would be wrong. But if you multiply the positive sign in, it would be correct. This is why I don't want you to use these rules if you don't know what you're doing. Okay, so I would say that in this case, if I write 2x minus 6, that is completely true. But if I have minus 2 here, and I want to do it exactly like brackets, that would be wrong. If you write this is equal to minus 2x plus 6, as we do with brackets, this is wrong. This is wrong, this is true, so don't use them. Okay, because we do not have, if I want to talk about absolute values, I can continue talking about absolute values until December. Okay, so forget about those things, just follow these rules, okay? Okay, so here, I hope that you agree, but this is an important question. Let me also a little bit talk about this, because I see that there is some discussion in the book as well about these rules. Let me just talk a little bit about those here. So I don't think, so we can solve everything with GeoGebra, so it is good. I hope that GeoGebra is also capable of solving inequalities, but then we will try to discover that one later probably. Okay, so let me just go down and then bring this up and go back to U, and then I can turn this off. Yes, and turn this on. So let me also discuss about, this is a good question that casual actually might be, this is a little bit of confusion, so let me discuss about these things. Okay. So something that you need to know about absolute values is this. For example, the absolute value of the product of two numbers is always equal to the absolute value of the first one multiplied by the absolute value of the second. Okay? So the absolute value of the product of two numbers is equal to the product of the absolute values of the numbers. This is for all. Let me write here. For all, this symbol means for all, x and y in the set of real numbers. So whenever you have x and y from the real numbers, the absolute value of the product is equal to the product of the absolute values. Of course, if I want to sell it to you in mathematics, I need to convince you that this is the case. But convincing you about this is not hard. You need to consider 4 cases. If x and y are both positive, what happens? If one of them is positive, the other one is negative, what happens? And if both of them are negative, then what happens? In all those cases, you should be able easily to convince yourself that the left-hand side is equal to the right-hand side. As simple as that. For example, if x is positive and y is also positive, what happens for x times y? Definitely this is also positive. And then if I ask you what is the absolute value of x times y, you say because x times y is positive, its absolute value is equal to itself. On the right hand side, absolute value of x is x itself, because I am assuming that x is positive. Absolute value of y is y itself, and when I multiply them, it's clear that they are the same. And then I need to consider another scenario. I need to consider one of them positive, for example, the other one negative. I have only four possibilities, yes? If x is positive, y is negative, then what would be the product? The product would definitely be negative. And then, what can I write instead of this? Because x, y is negative, absolute value of that is negative x times y. Okay? With question mark. Absolute value of x is x, because x is assumed to be positive. Absolute value of y is negative y, because it is assumed to be negative. Is this equality true? Yes. So you see that even in this case it will work. So you need to consider these things case by case. 4 cases, not that many. So if you do this case by case, you immediately will convince yourself that this is true. The same is true for division. Be careful. If I have the absolute value of a fraction, I can write it as the absolute value of the numerator divided by the absolute value of the denominator. But of course, it is clear that there should be one condition here, and that is the denominator shouldn't be equal to 0. But that's it. Don't go further. If you think that absolute value of x plus y is equal to absolute value of the first one plus absolute value of the second one, this is not true. Okay? An absolute value of x minus y equals to absolute value of x minus absolute value of y. It might be true, but by the way, in mathematics, when I say it is not true, it means that this is not the case. It is 100% true. It means that I cannot rely on that as a formula. So this is also not true. For example, let us try to convince ourselves that this is not the case. I cannot rely this as a formula. Be careful. These 2 formulas are correct, but they are not. For example, here, let me choose x to be 1. Let me choose y to be negative 3 for this one. Okay? And let me calculate the left-hand side. The left-hand side is absolute value of x plus y, but I have chosen x to be 1, plus I have chosen y to be minus 3. Then 1 plus minus 3 is minus 2, but I have absolute value around that, but we know the answer is 2. Now let me calculate the right-hand side. The right-hand side is absolute value of x plus absolute value of y. Absolute value of x is chosen to be 1, y has chosen to be minus 3. But what is the answer? Absolute value of 1 is 1, absolute value of minus 3 is plus 3, and then if I add them it becomes 4. And you see that they are not equal. So do not use these two as a formula. So you see that these things happens a lot. You know, for example, for the rule of powers, do you remember ab to the power of n is equal to an dot bn? But I emphasized a lot that a plus b to the power of n is not equal to an plus bn, yes? Do you remember? So this is for product, this is correct. For division, this is correct. But for addition and subtraction, this formula in general is not correct. Of course, I can find numbers that this will work. For example, if I choose x and y both positive, if I choose x equal to 1 and y equal to 3, then the left-hand side becomes 1 plus 3, 4. Absolute value of 4 is 4. Absolute value of 1 is 1. Absolute value of 3 is 3. And if I add them, it becomes 4. So it is sometimes true, but it is not a formula that I can rely on. Yes, is that understandable? Yes or no? Okay. So this is also in the book under the top, I don't know, discutir or something. So you are asked to discuss about these things. So it's good to know. Okay. And now let me go back to Kajal's question actually. So let us understand this. I told you that if you have 2 multiplied by x minus 3, you're allowed to send 2 inside. Yes? Why is that? Because am I allowed to, instead of 2, am I allowed to write absolute value of 2?
Yes.
Because absolute value of 2 and 2 are the same thing. And then multiplied by this absolute value. But now look at this formula. The absolute value, the product of 2 absolute values is equal to the absolute value of the product. So here I have 2 absolute values, I am multiplying them. According to this rule, I can write one absolute value and multiply the numbers. Yes? And then it becomes absolute value of 4x minus 6. So if you write this is equal to this, that's 100%.
Hold up now.
Yes?
4x.
No, sorry. 2x, thank you.
You're welcome.
Yes? So this is correct. But if I write minus 2 multiplied by absolute value of x minus 3, if you don't look at this step and you want to do this, if you want to do this and write minus 2x plus 6, this is wrong. Yes? The reason is that if I want to do this, why this was correct? Because instead of 2, I was able to write absolute value of 2. But here, minus 2 multiplied by x minus 3, can I write absolute value of minus 2 multiplied by x minus 3? Can I do that? If I can do this, yes, then I can continue like this. But I cannot do that. Why? Because absolute value of minus 2 is 2. It is not minus 2. So this part is wrong. You cannot continue. But if you want to, you can write it in this way. You can keep the negative sign here, and then instead of 2, put absolute value of 2. Yes? And then don't look at this minus sign, just copy and paste it, and then use this rule here. So this is also correct. So if you keep the negative sign out and then move 2 inside, that is also correct.
And how would that come handy, like in the previous question?
I wouldn't say it's too handy here, but if I want to follow what you said, I would write it as 5. I will keep the negative sign outside, and then I just multiply 2 inside. Then it becomes absolute value of 6x minus 2. It's not that handy. It's equal to 6, and then I have to follow the same process again. So I would say that for this number, there are 2 options. Either this one is 6 or this one is minus 6, yes? And then of course I move 5 to the left, it becomes 1, and this becomes 6x minus 1, minus 2 should be how much? Should be
1.
Should be minus 1, because minus 1 is 1, and so this is not acceptable, no solutions.
But
And then I have
a negative sign behind x.
But you cannot multiply this negative, okay.
But didn't you say we keep it, right?
Yeah, yes, I kept it in my mind. I did it 2 steps. So I moved 5 to the right. I kept this one. Then 6 minus 5 is 1. And then I multiplied by a minus sign. This minus sign is gone. That becomes, I did it quickly. But that is what I said. Okay, but here, then I go here, what happens? I move 5 to the left. Let me be patient and write it clearly. Then 5 goes there. It minus 6, minus 5, it becomes minus 11. Then I cancel this negative sign with that negative sign. Then I would say 6x minus 2 is either 11 or minus 11. Yes? If this is 11, so this is 13 divided by 6, I get that answer. If I move minus 2 to the right, it becomes 9, minus 9 divided by 6. But minus 9 divided by 6 is 3 over 2. So you see, if you do it correctly, this will be consistent. That is the whole point of mathematics. But you need to know the rules. Also, now that you understand it, you can memorize it somehow. If I have a negative number behind an absolute value, if I want to multiply the number inside the absolute value, I'm not allowed to move the negative sign inside. I have to keep the negative sign outside. Yes? Yeah, but I would prefer not to bother yourself with these details, okay? Any questions here? Yes?
What do you do in a situation when you have accurate values on both sides?
Yes, we will come to that.
You will come to that.
Yes.
Like just with the example, with the 6.
Yes, yeah, I have to give you examples and teach you how to do that. That's it. Okay, but before answering your question, having more than one absolute value becomes harder, but I want to increase the level gradually. So after number 3, let us go to this one. So let me choose the example in the book. I think that's a good example. So we want to solve this problem. The absolute value of x plus 1 is equal to 7 minus 2x. Okay, so it seems more or less the same thing, but be careful. I cannot follow the same as before. I cannot say that x plus 1 is plus or minus this number. Why is that? So you see, if I ask you to solve this equation for me, I don't know, 7, only 7 without any variables, then of course this is the simplest possible problem. You can say x plus 1 is either 7 or minus 7 and solve it. First of all, my question is that why this method collapses when it becomes here. So can I write this with the same strategy in mind? I would say that this is either or. I want you to understand this is not going to work. You see, the same idea that was working there is not working here, but I don't want you to memorize, I want you to understand that. Why this? So, first of all, do you think that this is more or less reasonable to think in this way? Because we were solving this problem and saying that x plus 1 is either plus 7 or minus 7. Now I am telling you that the same method will not work here if I do not have a constant, I have some variables involved as well. Why is that the case? Why do you think it shouldn't work? Yes?
Because when we multiply minus 1, it's minus negative 2x.
Yes?
So our variable changes.
No, that's not the reason. Of course, what's the problem of changing the variable? Which part of it is not reasonable? Because here, you see, do you agree with me? If I continue solving this, let me just do that, by the way. Let us not doubt about this. Assume that we want to do this way, that I am telling you it is wrong. So I have two options, 1 and 2. So let me solve number 1. What is happening? x plus 1 is equal to 7 minus 2x. I move minus 2x to the left, becomes positive 2x, 7 minus 1, and then I have 3x is equal to 6, x becomes equals to 2. How should I know that this is the correct answer or not? This you should be able to answer it. Test it. Test it where? In the original equation. Thank you. So I put 2 here. What is the answer? 2 plus 1, 3. Absolute value of 3 is 3. Put it here. 2 times 2 is 4. 7 minus 4 is 3. So that's okay. So that is really solution. It was not wrong. Yes? But let me go here and solve that one. If I want to solve that one, it becomes x plus 1. I multiply this negative sign in. It becomes negative 7 plus 2x. I have x and I move the 2x to the left. And I have minus 7. I move this to the right. And this becomes minus x. This becomes minus 8. And then what happens? I hope that this is not an answer. Yes, x becomes... Oh, sorry. I shouldn't put it in a box yet. But is this a solution? Let us check. 8 plus 1 is 9. Absolute value of 9 is 9. But put 8 here. 2 times 8 is 16. 7 minus 16 is minus 9. They are not equal. So that's a false root. And this will happen. And the reason is it is not unexpected. That's what I'm asking you. I want you to understand these things. So apparently I was doing something reasonably right. It was not unreasonable because at least I got one of the answers right. But I got another answer which is not actually a solution. Of course, you might say that I solved this problem and then I will find which one is the false root. I cross it over and then I will get this one. But my question is that what is the source of this false root? Why do you really expect? Why should you expect to get a false root if this is the case? The reason is that if I have given you from the beginning to solve, what do? If I give you this equation, you know how to do. But if I give you this equation, how do you solve the problem? Do you still write x plus 1 is plus or minus 7? No, you should write just no solutions and don't continue. Here, you see 7 is positive, you continue. Here, you see minus 7 is negative and you don't continue because that's hopeless.
Yes.
But here, do I know 7 minus 2x is positive or negative? No, because I don't know x. If x is a value so that this is positive, this is working, and you see that it was working for this case. But if 7 minus 2x is negative, and you don't see it is negative, you start continuing and finding an answer, but that answer is not acceptable because this one is negative under this condition. So what I'm saying is that if you have a variable on the right-hand side, this method will not work because you still don't know if this expression is positive or negative. If it is positive, you can continue, but if it is negative, you are not allowed to continue. But if you don't understand that, you will also continue for that one as well, this is why you get a false root. Yes? Do you agree with what is happening now? Okay. Now so this I want you to understand. There are many things that you can do, but let me just follow the most standard one. So the most standard one is to discuss and to get rid of the absolute value sign. So you see, I told you that absolute values are ubiquitous in mathematics, but whenever we want to solve something related to them, the first thing we need to do is to get rid of them. Yes? So how should I do that? How can I get rid of this absolute value? So you see, let us consider this geometrical point of view. So this is the x-axis. One point is minus 1. So let me, for example, consider this point somewhere, which is minus 1. Yes? This minus 1 divides the x-axis into 3 parts. Yes? Before minus 1, exactly at minus 1, and after minus 1. Yes? This is the whole possibility. You have to solve this problem in all cases. Okay? So what you need to do, you need to consider this, and you need to consider this, and you need to consider that. So here x is less than minus 1. Here x is equal to minus 1. Here x is greater than minus 1. But of course, I want you to learn not to solve it 3 cases. You can also always combine this equality with one of them. Okay. So what I do, I would say that the case x is less than minus 1. I am strictly on the left-hand side of minus 1. If x is less than minus 1, what can I conclude about x plus 1? Move it to the right, to the left, it becomes x plus 1 is smaller than 0. Agree?
Yes.
And then, if x plus 1 is smaller than 0, absolute value of x plus 1 is equal to what? Is minus x plus 1. Yes? So this is equal to minus x minus 1. So I have to break the problem into different regions. If x is strictly smaller than minus 1, hopefully you agree with me that x plus 1 is negative. And if I know that x plus 1 is negative, I can remove the absolute value signs. The price that I have to pay is to put the minus sign there. And then I multiply the minus sign, I got this one. Yes? Agree or not? Okay, now go back to your equation. Under this condition, I am not solving this equation in one go. I am solving this equation under this constraint. So instead of this expression, I can write minus x minus 1 on this region. Yes? So it becomes minus x minus 1 is equal to 7 minus 2x. Okay, so let me go horizontally this time. I move minus 2x to the left, it becomes positive 2x. I keep 7 on the right, I move minus 1 to the right, it becomes positive 1. When you go horizontally, you have to put these arrows, okay? And then you have x is equal to 8. But, be careful. Before accepting this, you have to go back and see your constraint. Because you are solving the whole thing here under this constraint. And what you got is 8. Is 8 in this constraint fulfilling this criterion?
No.
No. So it is not acceptable. So not acceptable. Yes, is that understandable?
Yes.
And now, is the problem solved? No, because I just considered one case. I have to go to the other one. To the other one is x equals to minus 1, but I would prefer to write x greater than or equal to minus 1. I am considering 3 cases. I consider this left-hand side with a strict inequality, and then I am considering equal or greater than minus 1. So it means that I am now considering everything starting from minus 1 onwards. Okay, so now help me again. You see the same thing. I move minus 1 to the left. It becomes non-negative. Agree? And now that I am sure that x plus 1 is non-negative, what can I write for absolute value if I want to? What can I write? On this
You can write x plus 1.
x plus 1, I just simply remove
Can I
that.
ask you a question?
Yes?
How come you're not writing, the condition, the criteria as x minus x plus 1 is more than 0? You understand that? Instead
No,
of
that is less than 0 because
no,
x
you're writing here x is more than minus 1.
Yes?
Why don't you write x is more than x plus 1 is more than 0? Why don't you write that instead?
Yeah, you can do that as well.
So you can do that. Alright.
Yes, the reason that I don't want to do it, because then we will face more than one absolute value signs.
Yeah.
Then not keeping track of individual numbers is easier than keeping track of expressions.
Alright.
Yeah, that's up to you. By the way, I am not very sensitive how you write this. As far as this is correct, that's correct, okay?
Alright.
But this is one way that I think if you follow systematically, it will solve the problem. Okay, then I go back to the equation again. Instead of absolute value of x plus 1, this time I can put x plus 1. Yes, instead of this one, I can put x plus 1. On the right hand side, I have to copy and paste. So then what happens? I move minus 2x to the left. I have 7, I move 1 to the right. Then it becomes 3x is equal to 6, and then I divide I want to make x alone, yes? When I divide by 3, it becomes 2. But be careful, before putting it in a box to accept it, you have to check it against your criterion for that part of the problem. Yes? I got x equals to 2 under this condition. Does that answer satisfies this condition?
No.
Yes, so that is acceptable. Yes, because 2 is greater than minus 1. Yes? This one is acceptable. Is that understandable? Okay. But these problems might be a little bit hard if you don't pay attention to the details. You always miss a minus sign and you mess up at the end. Okay, so you need to be careful about those things. So that was exactly the problem in the text of the book. I want to go to a harder one. I will also choose the one in the book. That's also a very nice problem. Okay, so any questions here? I don't know, should I increase the level? Right, let me increase the level. I don't think that's hard. Yeah, it's a little bit structural. You need to follow some structures and algorithm-wise steps. But if you get used to it, it's not hard. By the way, understanding the problem is always superior. Yes, you need to understand what is going on. So, and then you see that getting rid of absolute value sign is always necessary. Okay, so let me write another equation that is also in your book. So number 5, this is the equation given there. It is x plus 3 and then another absolute value sign, 2x minus 4 is equal to 19. By the way, it is not easy to guess the numbers. Yes, even if you find, was it 2?
No, I'm just guessing.
So even if you find one of them, then probably finding the other one might be a little bit hard. I want to explain this very patiently. It would be long, so please listen to me. And if you don't understand something in the middle, just ask it at that point, yes? Because then if I want to come back and explain it, it would be very lengthy. Okay, so here, how many absolute value signs you see in this equation? 2. So I have to get rid of both of them. That's what I'm saying. Always you need to get rid of the absolute value signs. But unfortunately, the value that matters for this one does not exactly matters for the second one. Why? For example, if I choose a number which is above minus 3, this is positive. Okay, but there is no guarantee that this one is positive there. Because the number that matters for this is minus 3. That's the border for this. Can you tell me what number is the border for this? What?
2.
2. Yes, because if I put 2 here, it becomes 0 exactly. Before 0 and after 0 is important for me. I want to see when it is positive, when it is negative. So the border, then the number that matters for this one, or the border of positiveness and negativeness for this one, starts from minus 3. But the border of positiveness and negativeness for this expression starts at 2. One number is minus 3, one number is 2. This, the way that I have done it in the book is really nice. So you just draw a picture for yourself, x. And then you have to respect the orders. The numbers that are relevant here is minus 3 and positive 2. So definitely minus 3 comes late before positive 2. And you really don't need to be precise in drawing the graph. Just put the important points for yourself. But keep the order. Minus 3 is on the left, 2 is on the right. How many regions now you see? Suddenly I have 3 regions. If you want to include these, 2 more on that, it would be 5. So before minus 3, at minus 3, between minus 3 and 2, at 2 and after 2. Yes? But what I want you to do, let us do it in this way. I consider this one x less than minus 3. Whatever is on the left hand side is less than minus 3. Whatever is here is between means this, yes? And whatever is here is greater than 2. Yes? But of course, if I write this, I am actually ignoring 2 points. One of them is minus 3, one of them is positive 2. You have to consider them as well somewhere. My recommendation and the way that I have used to it, I always I do not consider it the first time, I will consider it the second time. It is just, I don't know, this is my way. You can just do it, you can put equality here. Of course, you can also put equality here, but you are considering minus 3 2 times. Why should we do that? So I will not consider minus 3 here. I will consider minus 3 here. I didn't consider 2 here. I will consider 2 here. It doesn't matter. If you don't like, you can put equalities in below all of them. But what is important is that you have to make sure that you are considering all possible scenarios. Yes? And now you have to solve this one single equation in 3 steps. Here, there, and there. Yes? Okay, now tell me. Let us now follow, for example, what Hussein said. So here, I will consider x less than minus 3, one region. Let me just put a space here. Another region is this. Yes? And the next region would be so let me make it a little bit more compact this time. So the next region is x greater than or equal to 2. Okay? So here I think you can immediately convince yourself. So you can write x plus 3 here and 2x minus 4 here. You can write x plus 3 again here, 2x minus 4 here. You can write x plus 3 here, 2x minus 4 here. That is just for keeping track. So tell me, when I am on this region, what can I say about positiveness or negativeness of this number? I am choosing x is smaller than minus 3, and I am asking you, do you think for those x's that I am choosing in this region, this x plus 3 is positive or negative?
Negative.
Definitely negative.
Negative.
And what do you think about this expression on this region? You can choose one random point for yourself. For example, minus 4. And put it here. What do you get? Positive or negative at the end? Negative. So this is also negative here. Yes? Let us go to the next region. What do you think will happen for this in between minus 3 and 2?
Positive.
Positive or equal to 0. Yes? But what happens for 2x minus 4? Choose a number randomly between minus 3 and 2. For example, 0.
Yes.
And put 0 here. What do you get?
Negative.
Negative. So it is negative. And then go back here. So I think you immediately can convince yourself what is happening. So what is happening for x plus 3? If x is greater than 2, definitely positive.
Yes.
And this one?
Positive.
Positive or?
Equal to
Equal to 3. Yeah.
Yes? And then you can start solving the problems here. You see, concentrate here first. X is less than minus 3. I want to get rid of this absolute value. Can I get rid of this absolute value on this region? Yes, because in this region I am sure that this one is negative. So I can remove this, but the price that I have to pay is multiplied by a negative sign. Yes?
Yes.
And go to the next one. I have to get rid of this absolute value. Can I do it in this region? Yes, because in this region, again, I know that this expression is negative. So I can remove it. I mean, I can replace it by brackets, but the price that I have to pay is to multiply it by negative. And then equals to 19. But is this a problem to solve? No, this is a Math 1C problem. Yes? Because this is just a normal equation, you want to solve it. But you shouldn't be in a hurry. When you find the answer, you shouldn't put it in a box as an acceptable answer. You have to check the answer against your criterion here. If it doesn't satisfy, just cross it over. Yes? So let me just solve that problem. So I go horizontally because I need the space. So minus here, minus there, it becomes minus x minus 3. I multiply minus inside, it becomes minus 2x plus 4. And this is equal to 19. So let us do some part of it. You can do, of course, these parts in your head. So minus 3x is equal to what? This is 1, this is 18. And then I divide by minus 3 is minus 6. Before putting it in a box, you have to check it against your criterion for that part. Is it acceptable?
Yes.
Because only those values are acceptable which are smaller than minus 3, and minus 6 is also, of course, smaller. So I accept that. And of course, if you want to make sure everything works, you can put it back and check. Let us check that, okay, in our head. Minus 6 plus 3 is minus 3. Absolute value of minus 3 is 3. And then I put it here, minus 12. Minus 4 is minus 16. Absolute value of minus 16 is positive 16. And 3 plus 16 is 19. So that answer was correct. Yes? Okay. I think explanations and everything is enough. I want to test your understanding. Even I think, you think you can solve the other parts yourself?
No. Yes.
Do you want me to continue that? I think you can do it. Okay. So let me pause the recording and then try to give you the chance to solve these two parts yourself. But of course, the only thing that you need to be careful is the signs here. Yes. So I will pause the video and wait for you. Okay, so for example, what are your answers? Because I can see them in the book. Minus 6 I got, it was acceptable. The answers that you get for this one and that one, what are they?
Mine, 12 and 20 over 3.
Okay, both of them are acceptable or not?
12? No, 12 is not acceptable.
Minus 12 is not, thank you. So you see, it is not hard. It is lengthy, but it's not hard.
No, I think about.
Okay, so let us see how it goes.
Sorry?
What should I do? Again, let me explain everything in case you don't understand something. So I want to solve the problem in the middle region. In the middle region, I have already done everything. X plus 3 is non-negative. Can I remove this pair of absolute values? Yes. And I don't need to pay any price. I just turn it into a pair of brackets. But for 2x minus 4, I have to be careful because 2x minus 4 in the middle region is negative. So I can remove the pair of absolute value signs, but the price that I have to pay is to multiply it by a negative sign. And then I have 19 on the right. And then I open it up and solve it, yes? So this becomes x plus 3 minus 2x plus 4 is equal to 19. And then x minus 2x is minus x. Let us do it in our head. 3 plus 4 is 7. I move it to the right. It becomes negative 7, so it becomes 12. And as you predicted, the answer would be minus 12. But before being in hurry and accept it, I have to go back and check it against my criterion, which is not acceptable. Because I only accept those values which are between minus 3 and 2, but minus 12 is not. Yes? So not acceptable. And this is part of the problem. You have to write this thing or similar acceptable here. And we go actually to this one. On this one, I see that both of them are positive. I have already done that. So what happens is I can write x plus 3. And I really don't need to be careful at all. So it becomes 2x minus 4 is equal to 19. And then I remove the pair of brackets. Let us do it quickly. So this becomes 3x. 3 minus 4 is minus 1. I move it to the right. It becomes 1. It becomes 20. Yes? And then what happens? X becomes 20 over 3. But is that acceptable? 20 over 3 is around 6 something. Yes, it doesn't reach to 7, but it is... doesn't matter that much, it's acceptable. So when it is acceptable, if you want, you can write it or put it in a box. If it's not acceptable, you have to show me that you know it's not acceptable in the exam. Yes? So that's also this problem. Is that understandable? Yeah. Okay. Now, the tricky part is when it comes to inequalities. That is tricky. Okay, so you have to be very careful. I don't want to increase the level so much, so that let me see what type of the problems they are actually asking you to solve. Yes, sometimes they have quite hard ones with double star. So let me teach you from scratch. Okay, so let me clean this. So now we go to solving inequalities containing the absolute value sign. And I have to do it with examples as well. So let me write example. I don't know, for some reason they haven't talked about these famous inequalities separately. I think it's worth that you learn them separately. So I will put them in my example. So solve the following inequalities. Okay, by the way, let me refresh your memory a little bit. I hope that you haven't forgotten things from Math 1C. Do you remember what was an inequality?
No.
There are four signs there. One of them is this one, less than, or you can say less than or equal to, greater than or equal to. Yes? So less than or equal to, and this is greater than, and this is greater than or equal to, yes? Okay, but this is not hard. For example, it is clear this statement is true. 2 is less than 3. It's a true statement. But this is also equivalently can be written using the greater than sign. Yes? 2 less than 3 means 3 is greater than 2. I want you to understand. You see, I interchange the places. I also swap the sign. This is important because there is also another way to swapping the sign. Do you remember what was that?
No.
Yes? Negative or divide by a negative. If you multiply both sides of an inequality by a negative number, you have to remember, you have to flip the sign. Yes, and that is clear. If I want to multiply both sides by negative sign, if this is true and I don't understand that I have to swap the sign, I get a wrong statement. This statement is true. But if I just multiply this by negative sign, it becomes negative 2 is smaller than negative 3, which is false. Yes, because negative 2 is not a smaller, is greater than. The reason is that whenever you multiply by a negative sign, you have to remember to flip the sign. From less than to greater than, from less than or equal to greater than or equal to, or vice versa. So that is important. But you see here, there was also another way of flipping the sign, is just interchange the left-hand side and the right-hand side, then automatically it will be flipped. Because if I write 3 is smaller than 2, this is ridiculous, yes? 2 is smaller than, by the way, smaller than, I should read it less than. 2 is less than 3 is true, but if I write 3 is less than 2 is wrong, but I have to write 3 is greater than 2. So that is something that you need to know. But what is an inequality? An inequality I want to solve. For example, I give you x plus 2 less than 3 and I ask you to solve this. What do I mean by solving an inequality? I want you to find all possible values for x so that if you replace x with those values, this becomes a true statement. For example, is x equal to 0 an answer, a solution? Yes,
actually.
Because if you I put 0, 0 plus 2 is 2, 2 is less than 3 is a true statement. So 0 is one possibility. For example, is 5 a possibility here?
No.
No. But I cannot just randomly check all of those numbers. And the other point is that usually the inequalities have infinitely many solutions. Okay? So how should I find that? I solve it exactly like equalities. I add -2 to both sides. So this means that 2 will go there. And this becomes 3 minus 2. And then this becomes x less than 1. So this is it. I stop here. What is the meaning of this? I would say that whatever you choose for x, which is less than 1, will turn this inequality into a true statement. So this is my solution. So how many solutions I got? Infinitely many. Any number less than 1 works, but I have written it in a compact form as if it is one solution, but this is not one solution. Every number less than 1 is a solution. Yes? For example, if I want to solve this problem, 5 minus 2x less than 3x. So what should I do? I keep minus 2x on the left. So this time let me change the sign, for example, to this one. It doesn't matter. I keep minus 2x here. I move 3x to the left. It becomes minus 3x. I keep this sign like this. I move 5 to the right. It becomes negative 5. Minus 2x minus 3x is minus 5x. Is greater than or equal to minus 5. But the point is that I want to make x alone. To make x alone, I have to divide by this number. But this number is negative. So when you divide, let me write it patiently. So you divide by minus 5, the left-hand side. You divide the right-hand side by minus 5. But the number that you are dividing both sides by is a negative number. You need to just remember to flip the sign. Yes? And then minus 5 and minus 5 are gone, so x becomes alone. Less than or equal minus 5 divided by minus 5 is 1. So that's the answer. What is the interpretation of this? You would say that if I choose x to be 1 or less than 1, and I replace it here and there, this becomes a true statement. So that is the meaning of what you have got. That's the only thing that you need to remember from Math 1C. Okay, so let me let me start with two examples, which is not discussed in the book separately, but I see them in the problems. Of course, the general method also works for this case, but I don't want you to, because that would be time-consuming every time you want to use the general method. For example, if I ask you to solve this equation, what is your opinion about that? Let me start with the simplest possible case. Absolute value of x is less than 1. How do you solve this inequality? For simple inequalities, geometric interpretation is very, very handy. So, yes, Hussein?
X is either less than 1, or to change that it's minus x less than 1, and x is either less than 1 or more than 1.
No, you are solving it algebraically with a little bit of law. But from geometrical point of view, you don't need to do some effort, you know. What is the interpretation of absolute value of x? It is the distance from the point x to the origin. Yes? So it means that if you consider it geometrically, here is my origin. For example, assume that this is 1, this is 2, and this is minus 1, this is minus 2, etc., etc. I am interested in all those points so that the distance of those points to the origin, which was the geometric interpretation of this object, is less than 1. For example, can I be somewhere here? No, the distance is larger than 1. Can I be, for example, here? No. Can I be here? No. So, but can I be here? This is actually, can I be exactly on 1? No. Can I be exactly on minus 1? No. But where can I be then?
Between 1 and
minus
0.
1. No, more than that.
Sorry.
Between 1 and 0 is not wrong, but it is not the whole story. Between minus 1 and 1. Because my distance, if I start, by the way, I want to show that I don't consider this. So that is a hollow circle. It means that I am not considering these 2 points, but I am considering everything in between. Is that understandable? So if I am on this orange line, wherever on this orange line, my distance to O is definitely less than 1. Is that understandable? So if I ask you to solve this, the answering to this is very simple. You really don't need to discuss. That's it. It means x should be somewhere greater than minus 1, less than 1. Yes? Yes. Understandable or not? Okay, now let me ask you the question again. For here, I want to change this one. This time let me put equality as well. So I would write absolute value of x is greater than or equal to 1. How do you interpret this one now? This time I am interested in those points so that this object, which is the distance of that point to the origin, is equal to 1 or greater than 1. So if I draw this picture in my head, so here is O, here is, for example, 1, here is 2, and let us go -1, -2, etc., etc. Where on this x-axis I can be?
1 and 1.
So I have to keep the distance from myself to the origin either 1 or greater than 1. So which places, for example, I hope that you agree with me. Can I stand exactly on 1?
Yes.
Yes, in this case, yes. But can I stand somewhere here?
No.
Yes, everywhere here, my distance from the origin becomes larger than 1. I want to get it larger than 1, yes? But this is not the whole story because there are some other points. Where are those points? From -1 to the left. Yes? So can I be on -1?
Yes.
Yes, but I can also be on the left-hand side. So these two parts, these are rays in geometry. These two rays in total is the solution to this. This is geometrically. How should I write it algebraically? Be careful. So can you tell me how should I write it algebraically?
Maybe -1 is greater than or equal to x is greater than or equal to 1.
No, that is something tricky. Be careful. Just be reasonable here. Is there one region or more than one region in this case?
2.
2 regions. So you cannot say and.
Or.
Yes, you should say or. Either I am here or I am there. Yes? So if you want to answer this, you should say that either x is less than or equal to -1. It's extremely important. If you don't write this or, then that would be wrong. Or x is greater than or equal to 1. You see? If I ask you to solve this inequality, I am asking for finding all possible values for x so that after replacement, this becomes a true inequality. Do you agree that this is the answer or not? Did you understand what's going on? First of all, from geometrical point of view, you understand the problem, yes? Because you want to be at a point whose distance to the origin is 1 or larger than 1. So either you are on this side or on this side, yes? So you yourself say either here or there, so you need to write it. Either this one or that one, yes? You cannot write in between. By the way, can I write it as something similar to this? I want you to understand the difference between this symbol and that symbol.
Yeah.
This means what? This means that x is less than 1 and -1 is less than x. Yes? But we don't write this, we summarize it in this form. We say x is between -1 and 1. When we say x is between -1 and 1, it means on the one hand, it is smaller than 1, and on the other hand, it is greater than -1. Instead of writing this, we write it compactly. This you cannot write it compactly. You have to write it in this way. Be careful about that. Some people, I don't know, have seen people, some strange things. So I don't know, might be some people write it in that way. This is completely not possible, okay? So don't do these things, yes? Here, of course, here I recommend you to write it in summarized form. Here I am telling you, you have to avoid summarized form. There is no summarized form for this one. I think, let me not increase the level because we do not have time, but I don't know, the book hasn't talked about these simple ideas. They have only talked about the general one. But simple ideas are also very ubiquitous. And because the general method is very time consuming, I really recommend you to understand this from geometrical point of view so you can do it faster. Okay? Okay, thank you very much.
Thank you.
Yeah.
Den fick nästa torka.